Hi everyone, welcome back to my Number Sense channel, and in today's video, we are going to be talking about fraction to decimal conversion. But this is going to be what I call the most beautiful fraction in the world. It is, I think, like a magical fraction. You'll remember that in the last video, I talked about 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 8, 1 over 9, 1 over 11. Every number from 1 to 10 except for 1 over 7. And this is the video that I am reserving for 1 over 7 because I think it is such a cool and important fraction to know. So here it is. What is 1 over 7? Well, first of all, if you remember our last video, you should be able to reason that 1 over 7 is going to be an infinite decimal. Once more, it is an infinite repeating decimal. So what is it? Well, we can derive it using long division. So let's do that. And stay with me here because it might get a little bit long. But I promise you, it's going to be so cool. If you don't want to stick around for the long division, you can skip forward a little bit, but I am going to derive it just for mathematical purposes. So 0 point, now we have 10. So we have 7 goes into it once, get to 30. 7 goes into 30 4 times, get 28. 20 goes into it twice. 60 goes into it 8 times. 40, that will go into it 5 times. Finally, 50, it will go into it 7 times. Sorry for the wobbly handwriting down here. And now we have repeating it at 1. So you have 0.142857, and this is the part that repeats, because if you'll notice, we have a 1 down here, we start with a 1 up here, so it will repeat 0.142857 repeating. This is the magic fraction 1 over 7, the most beautiful fraction in the world. Now, at first glance, you might not see anything beautiful about this, right? It's just 142857. In fact, that's kind of a long repeating fraction, right? Even 1 over 11, that was only 0.0909. Why is this 6 digits long? Well, it's 6 digits long, but also we have 1, 2, 3, 4, 5, 6. There's something incredible that is about to happen. Because what is 2 over 7 then? 2 over 7, we can do it using long division, or we can multiply this by 2. And any way you do it, 2 over 7, this is what it's equal to. 0.285714 repeating. Look at that. Those are the exact same numbers in the exact same order, only rearranged a little bit. 142857? No, 285714. Why is this happening? Is it a coincidence? Well, to see it, what's 3 over 7? 3 over 7, well, if you use long division or if you multiply this by 3, what you're going to get is that 3 over 7 is 0.428571. Once again, it's the same numbers, right? 142857, 142857. This is the beautiful thing about 1 over 7. Anything over 7 is going to be like 1 over 7, but just with the digits slightly shifted, right? If we picture an infinite kind of row of 142857, 142857, right? Just the decimal expansion of 1 over 7. We can find, this is 1 over 7. This is 2 over 7. Over here is 3 over 7. You can find them just by shifting along this kind of infinite row of 142857. This is the really beautiful thing about 1 over 7, is that, I know I've said it already, but it's the same digits, just starting with a different one each time. And, just to complete the set, 4 over 7 equals 0.571428. What do you think 5 over 7 is equal to? It's going to be 0.714285, repeating. 6 over 7 is going to be 0.857142, repeating. This is 1 over 7, and it is really important in number sense to know, right? Because this is a special fraction, and they love to test you on special fractions. And this is a really, really, really unique thing. 7 is an extremely unique number because of this property that it has when you play with this. And so hopefully that can give you a kind of way to recognize what the over 7s are. But also, just in case you kind of forget, if you don't want to memorize all this, which I wouldn't want to either, there's a way you can kind of approximate it and then kind of figure it out. Okay, say for example, I'm trying to figure out what 4 over 7 is. Well, first of all, I should know that 1 over 7 is 0.142857. That's the most basic thing. Once I know that, I can kind of approximate what the others are. Because if I remember, 1 over 7, that's about 0.14. So 4 over 7 is going to be 0.14 times 4. It's about 0.56. But I also remember that it should be repeating. So 5, 6. What's something in that sequence that kind of looks like a 5, 6? Well, it's a 5, 7. And then once I know it's 5, 7, I can go, okay, what comes after 5, 7? Well, after 5, 7, this thing repeats again, so it's 1, 4, 2, 8. So it's 0.571428. And you can repeat this process with, like, for example, 5 over 7. 5 over 7, that's 5 times 0.14, which is 0.7. So it should be 0.7, but it can't be 0.70. It should be 0.7, 0.71. 71, what comes after 71? Well, after 1 is 4285, so it's 0.714285. I know I'm speaking a lot here, but hopefully that kind of makes sense, that you can approximate the over 7s by just thinking of 1 over 7 as 0.14 and then kind of using your knowledge that this pattern exists to build it up from there. So that is 1 over 7, 2 over 7, 3 over 7, 4 over 7, 5 over 7, and 6 over 7. Hopefully you see now why I want to give this its own video, because I've taken up an entire whiteboard with explaining this already. But just remember this, because this is going to be pretty interesting throughout the number sense series. And one last thing that I want to leave you with. What is 142857 times 7? Well, if you have this mathematical intuition, you might already be able to guess what it is. But in case you don't, here it is. 142857 times 7 equals 99999. Isn't that crazy? And this is only going to make more sense when I finally get into the video where I talk about every repeating decimal. And yes, 1 over 7 is going to be included in those. So really stay tuned for that. I hope this made you realize how cool 1 over 7 is as a number. Please remember this, and thanks you guys for watching. I'll see you in the next one.